So today, starting the class, process control. And this subject is interdisciplinary branch. So here, process control, we can divide it into two parts. First part is process, second part is control. Process mainly deals with modeling, whereas control mainly deals with how to control. Here mainly we will discuss about the controllers, just like on off, P controller, PI control, PD control, PID control. So this is the thing regarding the subject. This is mainly for interdisciplinary branch. So process mainly deals with the chemical engineers. Control mainly deals with the instrumentation engineers. Actually, the subject is mainly for interdisciplinary branch. I think everyone has idea about the interdisciplinary branch. Interdisciplinary branch means it is combination of two or more than branches. So here, if you want to design a controller, you should have an idea about the process, as well as you should idea about the controllers. Fine. Now I will write block diagram of automatic process control. Automatic process control block diagram. So this is very important. See, what is meant by automatic? What is the meaning? Replacement of human being. Replacement of human being, automatic. So we will see the block diagram. Here, this is my set point. This is my process variable. Generally, set point they will represent it with SP. Process variable they will represent it with PV. SP minus PV, you will get it as a error. That is generally E of T. So E of T will go to the controller. So what we discussed with the controller? Just like on off controller, P controller, PI controller, PD controller. This will a controller. Controller output will go to the actuator. Actuator output will go to the final control element. Final control element output will go to the process or plant. Both are the synonyms. This is a output, again we are giving for feedback element. So this is basically a measuring element. Measuring element. You come here. So this is the diagram. So here you will get controlled variable, see here the most important thing is the notation. The most important thing is the notation. You should be very familiar with the notation. See, controller output is what? Controller output we will represent with m of t. This is known as manipulated variable or controller variable. So this is very important. Controller output is m of t, that is manipulated variable or controller variable, whereas process output what we are getting is a controlled variable. So from here we are getting a feedback element we are using, again we are getting a process variable. Yes, error is nothing but what? Error is set point minus process variable, that is E of t equals to SP minus PV. Error is equals to SP minus PV. Now, whole our process control will deal with the input for the controller is error, output we are getting a manipulated variable. So, that thing, how it will gives the input to the actuator output, how it will go to the final control element, that will go to the process, again feedback, like this it will do it. So this is a very fundamental diagram for the process control. Fine. Now, what we will do means, we will take one physical process we will take. See, this is the example, but I want to give one practical example. Just, you can note down that practical example. Fine. Practical example. Practical example. See, now consider one system. See, this is a one pipe which is flowing, some liquid is flowing, some fluid is flowing. Yes, here I have one DP pressure sensor. What is the DP pressure sensor? What is meant by DP? DP is nothing but differential pressure. DP is nothing but it's a differential pressure. So this one output, it is going to P to I converter. P to I converter. So this one will give 3 to 15 psi. This is going to a controller. So that is, for controller I will give the set point. This is 4 to 20 milliamperes. Output I am getting, again I am getting current I to P converter. So this will, again I am giving to this is a valve. valve. This is pneumatic actuator. This is a flow pipe. This is what? Fine. Hello, are you? Just please concentrate. See, this is a very good example. So far we have discussed about the automatic control system block diagram. Now I have taken one physical process. This is what? A physical process. This is a physical process. See, on flow is going, on liquid level, just liquid is passing, so through a channel pipe. So, can you tell this one, this is where using I want to control the flow rate. So this is basically a orifice plate. Orifice plate, because first I have to measure that parameter. So that parameter I am measuring through the orifice plate. Orifice plate output is what? TP cell. TP means what? Differential pressure. How it will be measured? Q is equals to K into square root of delta P. This is a very important principle. This is based on the Bernoulli's principle, Bernoulli's equation. So discharge is nothing but K into square root of delta P. So that's why I am getting TP cell. So I am getting a pressure, for pressure as an input. So pressure will be converted into current. So that is I am getting 4 to 20 milliamperes. Because here the instrumentation standards are, this is very important thing, instrumentation standards 4 to 20 milliamperes current and 3 to 15 psi pressure. So this is very, very important. So being an instrumentation engineer, you should know these things. 4 milliamperes is known as live zero. 0 milliamperes is known as dead zero. So this is very, very important. You should remember this thing. 4 milliamperes live zero and 0 milliamperes dead zero. Now I am explaining why 4 milliamperes they kept as a live zero. Why 4 milliamperes only they kept as a live zero means, suppose if process has some problem or instrument device is not working, if they keep the 0 milliamperes, we don't know exactly. So that's why they kept as a 4 milliamperes. If some problem comes, that 4 milliamperes will come down to the 0, so that I can understand that some problem was there. Similarly, there is one thing is ISA, Instrumentation Society of Automation, ISA. So Instrumentation Society of Automation. So based on this standard, so they have designed 4 to 20 milliamperes. Any process variable will be converted into 4 to 20 milliamperes and pressure quantity will be converted into 3 to 15 psi. So this standard will be followed by all over international standard. Whoever they design the transmitter, they have to follow these norms. Okay. Here the pressure is converted into the current, that will be converted into the range of 4 to 20 milliamperes. This is given to the controller. So controller already we have given the set point, require this thing. So we are getting a process variable SP minus PV is error. Depending upon this error, again I am using I to P converter. So how much valve should be open? How much percentage of control valve should be open? So percentage of control valve should open like 5%, 20%, 30% or 100%. So that is will be given by electronically from I to P converter. So depending upon that, this valve will open. Again, flow rate will be measured by this one. Like this, it is a automatic control system. So this is an example for automatic control system. I think this diagram will help you to understand what is the process control. Hope that you understand about this diagram.